Hello everybody and welcome to exercise E. This is page 21 of the workbook that we're looking at here. They would like us to integrate e to the 2x over 3 plus 4e to the x. Okay, so let's first talk about the form of this integral that we're seeing. You might remember mentioning that there were four kind of common forms that come up in the integral table, and the denominator of this particular expression resembles the fourth of those. You might remember me saying something about a plus bu. Okay, so that suggests a possible substitution. If we think of that denominator as being a plus bu, then u would have to be e to the x. Let's try that substitution and just see if it works. Okay, so if u is e to the x, then derivative of u is just e to the x, and we'll stick a dx on the end. And if we get the dx by itself, we're going to divide e to the x to get the dx by itself, so du over e to the x is dx. Okay, let's see if we can make that substitution work for us. Okay, I'm going to clear away this clutter here. And if we rewrite our integral, let's see what's going to happen here. We're going to get e to the 2x in the top over 3 plus 4, and we called e to the x u, so we'll substitute that in. And then dx, we can see from our work, is du over e to the x. Okay, so far so good. Now, do we get any cancellation here looking at that expression? We actually do. The e to the x and the e to the 2x cancel and just give us 1 e to the x in the top. It's like we're subtracting exponents. 2x minus x gives us e to the x in the numerator. So this integral simplifies down to e to the x over 3 plus 4u times du. Okay, but now we've got a problem, because we've got this e to the x that's still in the integral, and we're not done with this u substitution until u is our only variable. So what do we do with that e to the x? Okay, well, you might remember we've been here before. We called this going fishing. We need to go fishing for an e to the x. Find something to replace the e to the x with. And luckily, we don't have to fish too far. U equals e to the x. We can see that from our work to the left. And so that stray e to the x can be replaced with a u. Okay, let me rewrite that. That u kind of looks like a 4. Okay, it's a u. Okay, so the question is, can we find a match for that in our integral tables? And remember that the direction that we kind of chose to go was to think of this denominator as being an a plus bu type of a form. So we're going to look in our table under the a plus bu forms. All right, and those are quite a ways into the table. Let's scroll, oh, actually not too far. Okay, here's our a plus bu forms. Can we find a formula that matches? Okay, and oh, actually it looks like the very first one in this case. Okay, the integral of u du over a plus bu, that looks exactly like what we were integrating. We just have to ask ourselves, what were the a and the b? Well, we had a 3 plus 4u in the denominator, so we're just going to be using a equals 3 and b equals 4. Okay, and this formula tells us that our antiderivative has to look like that. Okay, so we'll go back to the previous page and just write that antiderivative down. Okay, filling in the 3 and the 4 for the a and the b, and here's what we're going to get. 1 over 4 squared, 3 plus 4u, minus 3 ln absolute value of 3 plus 4u, plus a c. And I'm going to remind you where this came from. Okay, this is formula 47 with a equals 3 and b equals 4. That's where we got this antiderivative. Okay, and last step is just to simplify a little bit and substitute the u's back in. So let's see, 1 over 4 squared is 1 over 16, and then 3 plus 4u, but u is e to the x, minus 3 ln of the absolute value of 3 plus 4, that u is e to the x again, Stick our plus c on and we are done. Okay, there's our antiderivative.